Hi everyone, this lesson is for Algebra 2 honors students. This is Chapter 7, Long Division, Synthetic Division, and the Remainder Theorem. Day 2. So, a little bit of polynomial review. Just to get started, you have a degree and then you have a name. Polynomials that are expressions that are not polynomials would look something like this. Anything with a variable on the denominator is not a polynomial. Anything that is a square root of a variable, not a polynomial. Anything that is an absolute value of a variable, not a polynomial. And let's see, I would say, is that it? There must be something else. We'll get to it and I'll remember. So this right here, this is a degree 1. This is 1. This is x to the 0 power. So this is basically you take the highest degree when you're adding. When you're multiplying, you add the variable degrees up. But when you're adding or subtracting, it's just the highest degree power. So this is a first degree. We call first degrees, we call those, let's see, we have constant. And then we have linear. So constant is a 0 degree. We have first degree is what we call linear. Then we have second degree, and those are quadratic. We have third degree, and those are called cubics. We have fourth degree, those are quartics. We have fifth degree, which is quintic. And anything above that is, we don't have a name for, so you just call it like a 6th degree polynomial. So this right here, which is a first degree, is actually linear. So this is 1, 2, 3 terms. So we call this one right here a linear trinomial. So this is x to the 0, x to the 1, x squared. So we take the highest power, so this is 2nd degree, which is quadratic. So we call this a quadratic trinomial. This one right here is a division by a variable. This is not a polynomial. This is x or y to the 1 power, so that's a linear binomial. That's a 3rd power, so that's a cubic binomial, 2 terms. Let's see here. This xy is actually 1 plus 1, so that's a 2. 1 and 1 right here, so that's quadratic. But then this kind of trumps that. So that's 5, 6, 7. So this is a 7th degree trinomial. This is completely fine. The root, as long as it's not the variable is not under the root. And sometimes it can be kind of tricky. Like you'll see that, like 7, and then they'll go x, and you'll think, oh, is that a polynomial? So this is a polynomial, right? Because the x is not underneath the root. Anyway, this is a 2, 3. That's a cubic, because that 1, you add them. Cubic binomial. This is 3, 4, 5. That's a quintic monomial, 1-term monomial. And you don't ever count the constant in front, okay? Some tricks I've seen also is people put a pi, and you got to remember that's just a number, right? It represents a number. So that's going to be a 5th power. We don't count the pi. That's a 3 plus 2. That's a 5th power, which is a 5th power is quintic, and that's a monomial. And then lastly, you have, let's see here, we have 4 terms, so we don't have a name for that. We call it a 4-term polynomial, but the degree 2, 2, 1, 0. So this is a quadratic, 4-term quadratic polynomial. Okay, learning targets. We're going to do long division, and we're going to do synthetic division. And we're going to do a little bit of the remainder theorem. And I think we're going to hold off on the factor theorem until next class. Excuse me. Polynomial division. So for polynomial division, basically, you're going to start off dividing one number by another. So like if you have 5 over 6, that's actually saying the number 5 is divided by 6. Okay, so you're going to go like this. You're going to add zeros, right? And you do some, 6 goes into 5. No. 6 divides into 50. How many times? So let's see. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. So it'd go in 8 times. Put that number here. You multiply down. Subtract. the value, then you have a 2. Bring down the 0. 6 divides into 20 3 times, and 6 times 3 is 18. Okay, see how this was, you remember this? It's like, oh yeah, it's coming back. Oh, look, this is going to be repeating, right? So we're going to have a repeater right here. So this would be my answer, 0.83. Well, what's happening here is, how do you divide something like this? Well, 2 divides into the first number, 2 times 1. Get that number there. You put it down here. You subtract. 3 minus 2 is 1. Bring down the next number, which is 5. 2 divides into 15. 4, 5, 6, 7 times. 7 times 2. 7 times 2 is 14. Put that number there. I subtract. And I have that one value left. And so that's what my remainder is. In the past, you called it, in the past, some people, I would guess, have called it like this, and they would write an R1. Well, we don't do that, of course, anymore. To write the answer correctly, you would write it as in adding 1 over the divisor, so 1 over 2. And so that would be my answer. Keep in mind, and that's if I use it a fraction, of course. And then I could also keep going and just add decimals. And if I did that, I would get, right, 0.0 here. And then I bring down the 0, and then I get 0.5. Either way is fine. But the reality is this, is that if you have a remainder, all right, that means that it's not 0. If it's 0, that means that 2, would be a factor if it was 0. If I were to divide 18 by 2, right? 2 times 9, that's 18. Subtract, I get 0. If I have a 0 as a remainder, okay, that means that 2 is a factor of 18. But if I don't have a 0 as my remainder, if you remember when we were doing this, we didn't add that, and we had a 1 as a remainder. So that means that 2 is not a factor of 35. So that's what that means. That's what actually the remainder theorem says. Okay, and we're going to get to that in a minute. We're going to divide these by long division. It's going to be a little bit trickier. So in the last lesson, we had something like this, right? Where we saw x squared minus 3x minus 10 all over x plus 2. And we tried to factor. Remember that? Where we said, okay, well, this might factor. Maybe we use the discriminant test. And we have x plus 2. So we said x and x. To get 10, I would go minus 5. Negative 5, and then I would go positive 2. And then remember, we would say, oh, look, these right here could cancel if they are one solid term, and I would get x minus 5. So that would be my answer of these two divided by each other. But that's by division by factoring, okay? But we're actually going to do something called long division, and you actually need to know how to do this. So we're going to erase this, and I'm going to talk about doing long division. So in long division, you've got, just like in the previous screen, right? And I don't remember if we talked about this, but this number here, that's what we call the divisor. This number here is called the quotient, okay? This number is the remainder, if there is one. And the number on the inside right here, we call that the dividend. And you actually need to know that, okay? All right, so here we go. So this right here is my dividend. So we have x squared minus 3x minus 10. And then this right here is my divisor, x plus 2. And so we're going to do this. So it's a little bit, oops. Oh, why did I do that? Try to get that out of the way. Let's move this down a little bit. Okay, so let's do this. To do this, you're going to go x times what is x squared? So you're thinking x squared divided by x. What is that? X. So that basically means x times x is x squared. So the rule is, just like in regular division, okay, as soon as you get a number up here, then you multiply it out through. Remember, if I had 45 here and 3 here, 3 goes into that one time. I put the 3 here, right? 3 times 1. As soon as I put that number up here, then I multiply 3 times 1. So I'm going to go x times x, which is x squared. And then I'm going to say x times 2, because that has to be multiplied. Here I only have one term, but if I have two terms out front, then I actually need to multiply that by both. So that's going to be plus 2x. And then similarly, just like regular division, okay, as soon as you get your number down here, by multiplying 3 times 1, you subtract. Okay, same thing. Now I'm going to subtract, but I'm subtracting the entire quantity. So be careful, because this minus distributes. So it's going to be x squared minus x squared, gone. That should cancel. Then I have negative 3x minus 2x. And so that's going to be negative 5x. Then the next thing you do after, right, you subtract, you bring down the next term. Same thing. We're going to bring down our next term, which is negative 10. We start all over. X times what is negative 5x? So that's going to be negative 5. So you get that number up on top, and then you multiply it back through times both of these values. So negative 5 times x is negative 5x, and then negative 5 times 2 is negative 10. And remember, we're subtracting that quantity. So it's negative 5x minus negative 5x, which makes plus. These cancel. Negative 10 minus negative 10, those two, again, same thing, cancel, and I have 0. So I have 0 remainder, which basically means that I have no remainder. It means that this value right here, x minus 5, which we already knew because we did this by factoring before, x minus 5, that means x minus 5 is my solution. That's my quotient. Okay. Now, you can always check your work, and I know it's a little bit tedious to do this, but you can check your work, meaning I can go x plus 2. See, like if I went 3 times my solution, I should get 45, right? So if I go x plus 2 times x minus 5, and I multiply that through, I get x squared minus 5x plus 2x, and then minus 10. If I did this correctly, I should get what my dividend is. If I multiply my divisor by my quotient, I should get my dividend. And if I did that, happy campers, we have the right answer. Okay, let's try this again. Again, x plus 3 goes outside. That's my divisor. And then this value inside, x squared plus 7x plus 12, that's my dividend. Okay, so our job is to find the quotient. You know, what's the answer? All right, so what we're going to do, again, is you go x times what is x squared. So x times x. You get that number up here. As soon as you get the number on top, then you multiply it back through. X times x is x squared, and then x times 3. So x times x, and then x times 3. So that's going to be plus 3x. And we're going to subtract the quantity. X squared minus x squared is gone. That's 0. And every time that should happen. There, you should never get a value down here. It has to cancel every time. 7x minus 3x is 4x, and then bring down the next term, which is positive 12. So then you do this again. You say x times what? I'm going to erase this part because now we're on the next term. X times what is 4x? So that's going to be positive 4. Again, you get this number on top, and then you have to multiply it through. So 4 times x is 4x. And then 4 times 3 is 12. And so I'm going to subtract the quantity. 4 minus 4x, gone. 12 minus 12, also gone. 0 remainder, which basically means my quotient is going to be x plus 4. Okay? Now, this works really well when this is, definitely factored. Of course, you could also check your work by factoring, right? And saying, well, x plus 3, and this is x plus 4. And then x plus 3 down here. And then you're going to cancel this one term. You have to cancel as a quantity. And so your solution is x plus 4. So that's what, you may have done in the past, but now you have to know how to do long division. So how about this one, right? This, there was something that I forgot to tell you. See how this is, the variables have to be decreasing, and there can't be any holes. So for example, we have x squared, and then we have x to the 1 power, and then of course this is x to the 0 power, even though we don't see that there. See how it goes 2, 1, 0? If you're missing a value, like let's say that 7x was not there, then you would have to have a space saver. So it would be 0, x to the 1s. See how that? If that didn't have that value, you have to have a placeholder for the first degree, okay? All right, so here we are with this one, okay? And so I would ask you to pause the video and then to try to do this yourself, and then we'd come, and then, you know, definitely check your work with me. So try to do that, okay? I'm assuming you're back because you checked that you did this. X times what is x to the 4th? So we're gonna go with x to the 3rd, okay? And then x times x to the 3rd, you get that number up, and then I have to multiply. So x to the 3rd times x is x to the 4th. X to the 3rd times 1 is x to the 3rd. So that's going to be plus 1x to the 3rd. Okay. We're going to subtract this quantity. Okay. Let me erase this now. We're going to subtract that quantity, and we get 0 here. And then now I have negative 21 minus 1, which is negative 22. And then I got to bring down my next term, 2x squared. X times what is negative 22 x cubed? Well, that's going to be negative 22 x squared. So you get that number up, and then you multiply it through. So negative 22 x squared times x is going to give me negative 22 x to the 3rd. And then negative 22 x squared times 1 is also negative 22 x squared. So now we're going to subtract this quantity, okay, and then minus negative minus is plus, so that cancels. So now I have 2 minus negative. So 2 minus negative is plus. So that makes 24 x squared. Bring down the next term, which is plus x. So x times what is 24x squared? Well, it's going to be positive 24x. So then you get the number on top, and then you have to multiply it through. So 24x times x is going to be 24x squared. 24x times 1 is plus 24x. Now remember, again, I have to subtract this quantity. So we're going to go 24x minus 24x is gone. X minus 24x is negative 23x. I'm going to bring down my next term, which is plus 17. So now I'm going to go x times what is negative 23x. So that's going to be minus 23. Negative 23 times x is negative 23x. And negative 23 times 1 is negative 23. So I'm going to subtract this quantity. Again, these are going to cancel. And now I have 17 minus negative 23, which makes plus. 7 plus 3 is 10. Carry the 1, 2, 3, 4. I have no more terms to bring down. So that means that my answer is this right here, and then this value here is my remainder, which means that I have to write my remainder like this. Just like I was doing that other problem, we're going to add it like this and go 40 over my divisor, which is x plus 1, okay? And so my answer is all of this right here, like that. The same thing as division. You're going to get the same answer, but it's without all the extra stuff. It's like synthetic. So this is how you do this. You take this. This is our little box here, like that. And what goes in here is this value set equal to 0. So it would be x plus 2 equals 0. So that would be x equals negative 2. So what goes in our little x box is negative 2. And then what happens is you draw a line here like that. And then what goes here on the top is your dividend, okay? And that's going to be, but remember, it's synthetic division. So there's no variables, basically. And so this right here, x squared, there's just one x squared. And then a negative 3, and then a negative 10. And so what we're going to do here is the rule says you add down. So you add down, and then you multiply across like that. So you start off with 1. 1 plus no value is 1. So we added that. Now we're going to multiply across, okay? So we're going to go negative 2 times 1. So negative 2 times 1 is negative 2. So now I add down, and negative 3 and negative 2 is negative 5. And then I multiply across. Negative 5 times negative 2 is positive 10. Add down, that's 0. So what happened now is you have to remember that we had x here divided into x squared. So what that means is if you had an x squared divided by an x, what's left is x, and that's my first term here. Okay, so this 1 here, that 1 is basically 1x. If that was x squared, this is x. And then you have minus 5. And remember, it has to be decreasing. Remember what I said about you have to have a placeholder. So see how that was x squared and then x to the 1 and then x to the 0. We don't see that, but that's what that is. That's that way. My answer is x minus 5. So we basically did this actually 3 ways, right? We did it first by factoring and then dividing, right? The x plus 2. And then the second way we did this was long division. And now the third way we did this is synthetic division. So let's do another one. So again, you're going to have your little box, and your divisor, which is this value here, is going to be as if it was set equal to 0. So that would be a negative 3. And then the coefficients are right here, synthetic, without x's. So this is 1. So we have 1, and then 7, and then 12. And then, so remember, we add down. So 1 plus no value is 1. And we multiply across. So negative 3 times 1 is negative 3. Add down, multiply across. Add down, and we have a 0 remainder. So that what that basically means is x plus 3 is a factor of this expression. But to write the answer, remember you divided x squared by x, which is x. So this is going to be 1x, and then this is a plus 4, so you have positive 4. And so this is the answer after you divide. And yeah, this is a great way to check your answer instead of doing all the multiplication and stuff like that. Let's try this one. Okay, so we have a little box like this, and this is going to be negative 1. And then remember, you're going to put all the coefficients here. It's going to go 4, 3, 2, 1, and then no value. So we're good. We don't have to have any placeholders. So this is going to be 1, negative 21, 2, 1, and 17. It's just the coefficients. And then draw a straight line. And now remember, add down. 1 plus no value is 1. Multiply across, so that's negative 1. Add down, we get negative 22. Multiply across, positive 22. Add down, we get 24. Multiply across, I get negative 24. Add down, I get negative 23. Multiply across, negative times negative is positive, so I get positive 23. Add down, I get 40. And remember, this is x4, x to the 4th power, divided by 1x, right? X to the 1. So that means that my first term is x cubed. So I have 1x cubed minus 22x squared plus 24x minus 23. Remember, that's x to the 0, which means that this leftover value that's not a 0, that value right here, that's my remainder. And remember, how I have to write that is going to be plus 40 over my divisor, which is x plus 1. And so this is my answer. And this is actually, I'm going to go back a couple of slides. This is exactly what we did here. Remember, 40 being our remainder, and this is what we did with the long division. And I know synthetic division is just such a cool thing, but you do actually have to know long division. Find out if the following are zeros. So there's zeros if it's a factor. All right. They want you to use long division. So let's practice using long division. So we have 2 here. And then use your coefficients. We have 3, 2, 1, and 0. So we're good. So this is going to be a 1, negative 7, 13, and then 3. Oh, long division. Whoops. Silly me. I went right for synthetic. Okay. I'll probably check with synthetic. But anyway. Okay, sorry about that. X minus 2 on the outside. Here we go. So we have x cubed minus 7x squared plus 13x and then plus 3. So x times what is x cubed? So that would be x squared. keep the base, add the exponents. So x squared times x is x cubed. You put that value here. And then x squared times negative 2 is negative 2x squared. Remember, you get those values there, you subtract the quantity. So x cubed minus x cubed is gone. That's done. Negative 7 minus negative 2. So that makes plus, which makes it negative 5x squared. Bring down the next term. And then we go x times what is negative 5x squared. So that's going to be negative 5x. So negative 5x times x is negative 5x squared. And negative 5x times negative 2 is positive 10x. So we're going to subtract the quantity. These terms, the first term is going to cancel every time. 13 minus 10 is 3. And I'm going to bring down the next term, which is a plus 3. So x times what is 3x? So that's going to be 3. So plus 3. So 3 times x is 3x. And then 3 times negative 2 is negative 6. I'm going to subtract the quantity. 3x minus 3x will cancel. 3 minus negative 6 is plus, so that makes 9. So that means that my answer is going to be x squared minus 5x plus 3 plus 9 over my divisor, which is x minus 2. Now, of course, you always want the right answer, especially when you know you can check your work. So let's do that. Let's do this by synthetic division. And remember, what goes in here is setting this divisor equal to 0. So that's going to be x minus 2 equals 0, so x equals 2. And then my coefficients are going to be 1, negative 7, 13, and 3. So we're going to draw our line. Remember, we add down, and then we multiply across. So that's going to be negative 5 times 2 is negative 10. Add down, multiply across, add down. And so remember, it was x cubed divided by x. And so this first term is going to be 1x squared. Then it's going to go down in descending order. So then it'll be minus 5x to the 1 plus 3x to the 0, but we don't write that. And then this value here is my remainder, and we write it like this, 9 over my divisor, which is x minus 2. And so we set that, that's our synthetic division, and that equals our long division, so we're happy campers. Okay, find out if the following are zeros. Now, of course, I can use long division, and I'm going to show you what happens when I do that, because as you notice here, there's an x to the 5th and then an x to the 0. So we have x to the 5th, but we have no x to the 4th. We have no x to the 3rd. We have no x to the 2nd. We have no x, and then we have plus 243. And so what's happened is this is like extreme, but I did have to make placeholders. So x times what is x to the 5th? So that's going to be x to the 4th. So x to the 4th times x is x to the 5th. That goes here. X to the 4th times 3 is going to be positive 3x to the 4th. Now remember, we have to subtract the quantity. The first term should cancel. 0 minus 3 is negative 3x to the 4th. Bring down the next term, which is 0x to the 3rd. X times negative 3x to the 3rd is going to be negative 3x to the 4th. So negative 3x to the 3rd times x is negative 3x to the 4th. Negative 3x cubed times 3 is negative 9x to the 3rd. Subtract the quantity. Negative, negative cancels. 0 minus negative 9 is positive 9x cubed. Bring down the next term, which is 0x squared. Okay? X times what is 9x cubed, so that would be 9x squared. So 9x squared times x is going to be 9x cubed. 9x squared times 3 is going to be 27x squared. Subtract the quantity, and I end up getting cancels. 0 minus that is negative 27x squared. Bring down the 0x. X times what is negative 27, so that's going to be negative 27x times x is negative 27x squared. Negative 27x times 3 is negative 81x, and then I'm going to subtract the quantity, and these cancel. 0 minus negative 81 is 81x, and now finally I get to bring down, oops, now finally I get to bring down the 243. So let's bring that down. So plus 243. I think I might need a calculator here. X times what is 81x? So this is going to be plus 81. And then 81 times x is 81x. And then 81, right? 81 times 3 is 243. So I didn't need a calculator. And these are going to subtract the quantity. I end up getting 0 as my remainder, which basically means x plus 3 is a factor of x to the 5th plus 243. So this is my answer. Super cool. That's my dividend, or excuse me, my quotient. And yeah, you could check it with synthetic division as well. So here, consider this polynomial. I want you to state the zeros. So if I wanted to state the zeros for this polynomial, I would need to know my zeros. Remember what you're asking. If I'm like in the previous problem, I had 0 remainder, which means that that factor that went in, that factor which was what, x plus 3 is a factor, which means at negative 3, that's a factor. That means that my graph crosses here at negative 3. So if I'm looking for zeros, right? So I'm looking for zeros for this polynomial. What would you try to factor? I mean, like, what would you plug in? And I'm actually not going to use long division. I'm going to use synthetic division. And the reason for that is because I'm looking for like all the factors. I don't know what they are. So I'm going to use synthetic. So that means that like I would try to factors of 6. Let's just try, I don't know, negative 2. So we have 3, 2, 1, 0. So I don't have any holes. So we have 1, 2, negative 5, and then negative 6. Let's see if this works. Add down, multiply across. Add down, multiply across. That's 0, right? Yep. Add down, multiply across. Okay, that's not going to give me a 0. What that did give me was a remainder of 4, which means this. When I plugged in negative 2, I got 4. So when I plug in negative 2, I got 4 for y. And so therefore, this is not a 0, but it actually is a point. So negative 2, 4 is a point on my graph. Okay, still I'm looking for 0. So now I'm not going to try negative 2. I'm going to erase all of this here. Okay, I'm going to erase this because I'm still trying to find a 0. Okay, so instead of trying negative 2, let's try positive 2 and see what happens. Okay, 1, multiply across, add down, multiply across, add down, multiply across, add down. So we found a 0 at 2, 0. So basically what happens now is this, okay? You're going to plug in these values, okay? And so like we know that x minus 2, right? Because that's where that came from, times this whole leftover. If I had x cubed and I divided it by my x minus 2, or the x, I have left x squared. So that's 1x squared. And then we have plus 4x and then plus 3, okay? I'm still looking for my zeros. So I have the 1, which is at 2, 0, all right? But I want to get another one. I know that I should get another one, and I can just do that by just simply factoring here. See this? X plus 3 and x plus 1. That's factoring this top. So that means that, this is what this means, that 2 is a 0, x equals 2. Negative 3, x equals negative 3 is a 0. And x equals negative 1 is a 0. So I have a 0 at negative 1, I have a 0 at 2, and I have a 0 at negative 3. And what if I plug in 0 for x? 0, 0, 0. At 0, I also have negative 6. So what realistically we're going to be doing is we are moving forward to graphing these polynomials. And so first off, if you see this x cubed, what that means is your graph should cross 3 times. 1, 2, 3, check. It also means that if you can follow this like this, you follow this Kind of goes like that, doesn't it? Okay, that's this polynomial. So like if I were to graph this, if I were to graph this, if I were to graph, sorry about that. If I were to graph this right here, what would happen is that I have 3 places and that it crosses the x-axis. And because it's a cubic, because it's an odd value, exponent, it's going to go up right and down left like this, like a cubic, like this. Y equals x cubed. What does that look like? It looks like this with your right arm up. That's what that is. That's my right arm up, and this is my left arm down. That's what the gist of this equation is going to look like. And so that's where we're at right there. That's cool. Okay, let's try this one. Okay, I'm going to use synthetic division, and which means that what goes in this box is 2. And then what this is, so I want you to be careful because that's x cubed, right? So do I have an x squared? I don't. So that I have to add in my 0x squared. So we have 1x cubed, so 1 here. I have a negative, I have no x squareds. And then I have a negative 2x to the 1, and then a negative 5. So what we do is we add down, and we multiply across, add down, multiply across, add down, multiply across, add down, and I get negative 1. Okay, so this is a remainder. And what that means is, and that's what they're asking me to do, is to find the remainder. Okay, so when I find the remainder, all right, what that's telling me is that my graph, whatever it is going to have a point at 2, negative 1. It also means that I can rewrite this like this. It was x cubed, remember to start, and this is x to the 1. So that means that my first term is going to be an x squared term. So we have 1x squared. This is now my x term, so plus 2x plus 2. And then remember, the way you write a remainder is you add this value. So it's going to be plus this value over your divisor, which is x minus 2. Okay? And if I did want to graph that, just for fun, right? I know that my graph is going to go through 2, negative 1 here. And I also know that I have a 0 for y-intercept, right? At 0, negative 5. So 0 down here, negative 5. But that, like, it's a cubic. It doesn't really help unless I plot more points. So, you know, I know that it's a positive x cubed. So it would look like this with my right arm up. But I'm not going to worry about that. And this is what we call this, because the right arm up, we call this EB, which is actually called end behavior. So what's the end behavior of your graph? So what this is what we've been talking about, is our remainder theorem. And it basically means that if you take a number and substitute it in for x, like, for example, negative 4, and you want to know if it's a 0, well, it's a 0 if, or a factor if, negative 4, when I plug it in, gives me 0. So if I plugged in negative 4, I'm going to get negative 4 to the 3rd power plus 8 times negative 4 to the 2nd power plus 8 times negative 4, and then minus 32. So I would actually use my calculator for this, and I'm going to do that right now. Okay, so I'm going to say negative 4 to the 3rd power, and I'm going to add 8 times negative 4 squared, and I'm going to subtract 32, and then subtract 32, and I end up getting 0. So f of negative 4 equals 0, which what that means is determine if this is a 0. If you end up getting this to be a 0 when you plug this value in, then yes, it's a 0. So you can just plug this value in to your equation, and that's called the remainder theorem. If you have no remainder, that means it's a factor, or that means it's a 0. And remember, a 0 means that it's crossing the x-axis at that value. Now, don't forget, we could have used synthetic division, of course, and we could have said, well, let's see, can we plug in negative 4? If I did that, I get 1, so 3, 2, 1, 0. You always have to check that. So 1, 8, 8, negative 32. Now, this isn't the remainder theorem. The remainder theorem is what this is, where you actually plug in -4 into your equation. But we're checking this with synthetic division. So 1 here, -4, add down, multiply across, add down, multiply across, add down. See how I got 0 here? What that means is that that's a 0. And so because it's a 0, it means it's a factor. That means that x plus 4 is a factor of this value. And similarly, sometimes you can factor, so like the leftover would be this here, which is x squared plus 4x minus 8. And 8, 2, 4, that's not going to factor. And so what that means is that I would have to do something else to like use a quadratic formula to find the other 2 factors. The remainder theorem means we don't always have to divide to show us that it's a factor. We can just simply use f of c, which means plug it in. So if I want to show, this is using the remainder theorem, show that this is a factor, or is that's a 0. If I want to show that that's a 0, and you use synthetic division, you just got 0 points. You just earned 0 points. Because if I say use the remainder theorem, you have to use the remainder theorem. So that means this. It means to show that x minus 3 is a 0, you're going to set that equal to 0, which means x could be 3. So we're going to plug that in. So we're going to go, well, what's f of 3? Okay, well, that's going to be 3 cubed minus 6 times 3 squared plus 11 times 3 minus 6. This is the remainder theorem. And so we're searching for a 0 here. So this is going to be what? 27. 9 times 6, so minus 54, plus 33, and then subtract 6. So what is that? 27. So 27 minus 54, add 33, subtract 6, I get 0. So f of 3 is equal to 0. And then this means, therefore, x minus 3 is a 0, which also means a factor, okay, of the polynomial f of x. That's what that means. And let's consider this. Find p of -1 and find p of 3. So this would be -1 cubed plus 2 times -1 squared minus 5 times -1, and then subtract 6. So we have -1, that's 1, plus 2, which is 1. So 1 plus 5 is 6. 6 minus 6 is 0. So what that means is that x plus 1 is a 0 of p of x. Okay, that's what that means. It also means it's a factor. All right. But without using synthetic division, what this means is that all we know that it's a factor, but we don't know all the factors. So if you use synthetic division, what happens is that there's a possibility for you to get the other factors, right? So if you have 1, 2, 3, 2, 1, 0. So 1, 2, 5, -5, and -6. And we just check -1. So let's see, 1, add down, multiply across, add down, multiply across, add down, multiply across, add down. So we know that that's a 0, but what's left is this, x squared plus x minus 6. And so what this did here was this said x plus 1 is a factor. That's what it means. But then what I have left here, if I factored that, so x plus 3 and x minus 2, so realistically, I've got x plus 1, x plus 3, and I've got x minus 2, which means that not only is -1 a factor, right, a 0, but it also means that -3 is a factor and 2 is a factor. So if I were to graph this, there's -1, that makes -3, this is 2, and my 0, remember what my y-intercept is. If I set x equal to 0, so 0, -6. So way down here, 0, -6. And remember, this is an x cubed, right? Right arm up. So my end behavior is right arm up, okay, looking like this. So I can sketch my polynomial pretty good. So I know this is going to go up. This is going to come down, come back down. That's my polynomial, and that's my sketch of my polynomial. If you're getting this, you're doing really well. This is tricky. Okay, use the remainder theorem to figure out if x plus 6 is a factor. I don't actually have to go down 4, 3, 2, 1, 0. I don't have to do that, because to figure out if this is a factor and I'm using the remainder theorem, all I have to do is take that x plus 6, because if it is a factor, then it's a 0, which means that x would equal negative 6 if it was a 0. So I would plug in negative 6, and then just use your calculator, negative 6 to the 4th power plus 8 times negative 6 cubed plus 5 times negative 6 squared minus 38 times negative 6, and then add 24. You know, whatever that is. If this is a 0, then if it's a factor, then it is a 0. Okay, and that's what it is. And so you just have to work that out. You can do that. I'm not going to do that. Okay. For this problem here, we're going to use synthetic division, and we want to know if negative 2 is a factor. X minus 2 is a factor. We're going to use synthetic division, and instead of the remainder theorem, we're going to use synthetic division, which means that, again, set that equal to 0, so we know that x equals 2. If it's a factor, we plug in 2 here. Now remember, it's got to go 3, 2, 1, 0, but there's no x to the 1 power. So this is going to be 1x cubed minus 3x squared. I have no x to the 1 power, and then minus 2. Okay, so let's do this. Add down 1, multiply across 2, add down, what is that, negative 1, multiply across, so negative 2, add down, multiply across, I get negative 4, add down, I get negative 6. So this right here is not 0. So if that's not 0, therefore, this is not a factor. Not a factor. But what it is a point. And so when I plugged in 2 and I got negative 6, that's a point. That's what that means. It's not a factor, no. But it is a point. It just because you're not getting a 0 doesn't mean that, you know, now it's useless, okay? I don't want you to forget either that we have calculators, and you should be plugging these values into your calculator as well. And you can also use a table on your calculator to verify, you know, what's a factor, what my points are, what my graph is going to look like. I know that this is an x cubed. I know that my end behavior is going to be upright and then down left. You just know that because this is odd. Y equals x cubed. You know it's going to be a right arm up. So even though I'm going over to negative 6 and I've got a point, and I also actually know the y-intercept, which is negative 2. I don't have enough information unless I plot more points. I don't have enough information to actually graph this unless I, you know, graphed it on my calculator or something like that, or plotted more points. So lastly, you know, we're almost done here. Use the remainder theorem to evaluate this. So, you know, again, anytime I ask you for the remainder theorem, you plug in the value. There's 3. So that's 6 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 17. Okay, let's do this one. We could do this one. This is what, 27? Okay, so we have 27 times 6, which is 162 minus 9 times 5, so minus 45. And then we're going to add 12. So we're going to add 12. And then we're going to subtract 17 minus 17, and I get 112. So that means that f of 3 is equal to 112, which therefore, that means that x minus 3 as a quantity is not a factor, but is a point at 3, 112. That's what that means. Okay, so just let's divide this and see where we're at with this. Remember when we started yesterday, the last class, and we had rational algebraic functions. That's what these are. These are two polynomials divided together, which does not mean you get a polynomial. Because remember, polynomials are continuous with no breaks. Any graph that looks like this is not a polynomial, okay? So a polynomial is continuous. That obviously has asymptotes and holes possibly. Okay, so we're going to factor this on top. I could totally use synthetic division, or I could do this. Watch, x minus 1 here. I could go, so that's x to the 4th. I have no x cubed. I have no x squared. I have no x, and then minus 1. You can do that. You can use synthetic division. But remember, you have to set this equal to 0, right? And so when doing that, that's a 1. But here we go. We've got a 1 here, 1x to the 4th, no x cubed, no x squared, no x, and then subtract 1. This is going to be super easy for synthetic division. Add down 1, multiply across, add down, multiply across, add down, multiply across, add down, multiply across, 0. That means that, therefore, it means that x minus 1 is a factor, okay, number 1, that's what that means. Also, I know that based on my solution, remember it's x to the 4th divided by x, which leaves me, my first term has to be x cubed. So that'll be x cubed plus 1x squared plus 1x plus 1. So that's what I have left, right? And no remainder. So this is, this is basically this times this, x minus 1, is this value inside. That's my dividend, okay? Another option is to factor, okay? And in doing that, and you just have to see how they ask you it. This is going to be x squared plus 1 and x squared minus 1, okay? And this is over x minus 1. You still can't factor anything out, but I do notice that this x squared plus 1, can't touch it. But this is a difference of 2 squares, right? This right here. And so that's going to be x plus 1 times x minus 1. And this is all over x minus 1. And what that means now is that one of these quantities, this x minus 1 and this x minus 1, cancels out. And so I'm actually left with x squared plus 1 times x plus 1, which, because see that these canceled out, is this value here, right? Which means, because that's a factor, which means that this value left over is this right here, factored. Okay, do you see that? Okay, right on. All right, moving on. One more problem, and this is cube. Remember that, cube, which if I were to factor that, if I were to factor this f of x on the top for review, we're going to do binomial, trinomial. Remember, same, opposite, plus. So this will be x here. This will be 2. Cube root of x cubed is x. Cube root of 8 is 2. X times what is x cubed? So that's going to be x squared. 2 times what is 8? So that'll be 4. And then multiply these two terms together and you get 2x. And then on the denominator, you have x plus 2. Unfortunately, nothing canceled. So that means that x plus 2 is not a factor. So what that means is that this didn't help us very much. Realistically, if you remember what I was saying in the other lesson, I know that at x minus 2, right, I have an asymptote. I know it's top heavy, which I know we haven't done this yet, so I'm going to have to hold off on that. But it also means that I do have an x-intercept of 2, and then I have an x-intercept wherever this value is, and that might be imaginary. If I set x equal to 0, meaning that's gone, I do have a y-intercept at -4 right here. So you should graph this on Desmos, see what you get, but at the same time, the problem is you have to divide this. So you can either do long division, okay, which means x plus 2 here, and you go like this, right? And you're going to have x cubed, but you have no x squared, and you have no x, but you do have a -8. And so by doing long division, you're going to get the same thing as if I were to use synthetic division. So that would be a 1, 0, 0, -8. And in my little box here, I put -2, because remember, you have to set this equal to 0. We're going to add down, multiply across, add down, multiply across, add down, multiply across, add down. So what that means is that my answer for this, if they ask me to divide, x cubed divided by x, is going to be 1, that's where this comes from, 1x squared minus 2x plus 4, and then this -16 is my remainder, and I put that over my divisor. And so the correct way of writing this solution is just like this. You could also go plus -16. That's totally fine. Right. Okay, so lots of stuff today. We talked about different types of polynomials. We talked about only this end behavior right here. We haven't done this yet. We talked about, nope, not yet. We did a little bit of graphing. We did long division. We did remainder theorem. We haven't done the factor theorem yet. And we've done synthetic division. So we still have quite a lot to do in this chapter, but we did fit a lot in. Your homework, basically, we did our learning targets. Just finished watching Endgame. Yeah, awesome. Homework is page 346, 1 to 9 odd. You are doing long division, and you are checking your solutions with synthetic division. Not too bad for tonight. All right, thanks for watching.